Okay, let's talk about permutation 2. So permutation 2 is actually similar to permutation 1, which is 46. So if you didn't watch the 46, just go back to watch. And what's the difference between 46 and 47 is actually the integer could be duplicated in an integer array. So you actually have to avoid the duplicate. So the best way is you sort it, and when you traverse in the for loop, right, you can actually check if the previous one is used. If the previous one is assigned, right, it's assigned to you, and the previous one is not used, because when you will call backtrack, right? So I'm going to talk deeply over there, but let's just think about it. Why we have to sort it? Because um, I mean, the second one could be the last, could be the last position, right? So we have to make sure the array is sorted. So when we compare the previous one, is actually equal to the itself, so you can actually skip it, right? So this is the first step. So I'm just basically use the 46 code and just add some implementation to run this code. So let's check about the duplicate stuff. So how do you avoid duplicate? So when I equal to 0, right, you are actually using the first integer. So first integer could not be duplicate, right, because that is unique. What happens when I equal to 1? When I equal to 1, actually this could be duplicated with the first one, right? So when I greater than 0, which means you are at a second position or third position, it doesn't matter, but it's not the first position in the array, right? So when I greater than 0 and num size equal to num size minus 1. Why? Because we already sorted, so we can actually check if they are the same. When they are the same, you can actually check the previous one is used or not used, and make sure it's not used, because you actually use the backtrack to set equal to false. So when first A and first one and second one, so first one and second one cannot be swapped, and it cannot sort into the list because they are actually equivalent to the first one and the second one and then two, right? It's actually not the difference between the second one and first one and two, right? So this is how you distinguish the list. So if you didn't actually understand, I got some discussion. I mean, someone explained pretty well. So just go on this post and uh, give credit to this guy. So the difficulty is to handle the big duplicate. So this guy is actually it's actually explained pretty well the first A, first B, and two A. And you actually don't want to add both of these into it because it's actually equivalent to itself. So the order does make difference, right? So by using numsci minus 1 numsci and not use, we can actually make sure that 1b cannot be chosen before 1a. This is how we actually avoid the duplicate. We don't want to choose the first a when we add first one when we add the second one. So if you still don't get it, you can actually visit this picture. So he actually explained pretty well when condition 1 is not used and used. So they just quickly talk about, so for not used, when I equal to 0, I equal to 1, I equal to 2. So which I will explain why you didn't use I equal to 2 over here. At the beginning, you have false, 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 right? And when you say I equal to 1, it's actually you say equal to true, right? Because we already say equal to true over here. When you add it, you just say equal to true, right? So this is why we don't want to use the I equal to 0 and I equal to 2, because when you actually traverse into I equal to 1, you have another for loop. And you already know when I equal to 0, I equal to 1 are visited, so I equal to 2 is not visited, so you actually add the number into it. So I 1, 2, 2 for this example. And when I equal to 1, so when I equal to 1, I equal to 0 is not used, and I equal to 2 is not used, because you have another for loop to run it, right? So I equal to 1, I equal to 0, and then you just keep going on this diagram, you can actually come up with this list. And when I equal to 1, I equal to 2, I equal to 0, and this will be your list. And I equal to 2 is not used because we can actually finish the entire backtrack or recursion for the I equal to 2 before you code yourself. So this will be actually avoid the duplicate. And let's talk about this. not we actually did use the one before. So the concepts are pretty similar, but think about it, this case will never reach recursive recursive case, right? The above condition is always true. So in this example is actually not not good. So this condition can also be used, but in some case, we are taking path that will never reach the best case. So I mean, when we go back to the code, so when we actually use the number and when we backtrack, right, we have to set it to false, and this is the hint. We know the integer in the array is used, so you can actually know we use the array, we use the integer in the array, so it's actually false, right? But false and false, right? So I mean, so this will become true, right? False and then false, false. I mean, which is true, right? So you can actually continue the number. So this is actually avoid the duplicate. So I mean, if you run like this, it's still working, but the test cases are pretty weak. But when you update the test case, you can actually run into a problem. So this is pretty good. Let's talk about the time and space complexity. So for time and space, for space, let's think about it. So for index 0 position, how many integer you can actually pick from 0 position? You see, it is 3, right? So which is n. And how about the second position? N minus 1, right? Which is 2. How about the last one? Which is n minus, n minus 1, n minus 2. So n times n minus 1 times n minus 2 and then times n, right? So which is 3 times 2 times 1, which is n factorial, right? I mean, if you actually follow the permutation rule, it's actually n factorial. So the space is n factorial. How about the time? So time is n factorial as well. Why? Because when you call yourself, when I to the 0, right? When you visit, and you will also call yourself again, and you are still going to check how many position, how many integer left I can use for this position, right? So we have a Boolean array. So this is how we can avoid like recurses many times. So it's n factorial in the time and space. So that will be the solution, and it's pretty hard to explain for this. And I hope you get it, and good luck.